Welcome back. This is the fourth video in this series, and this is more relevant for the industry. We would be discussing how to estimate the carbon footprint for industry. We live in an industrial world, and the contribution of industry to global warming is huge. So, how do we estimate the greenhouse gas emissions for industry? That is being the objective of this lecture. Before that, we need to be very sure about the concepts learned earlier. In case you have not understood the very crucial concept of calculation of emission factor calculations, I would advise you to go back to the video 3, get the concepts cleared, because that is what would be again required for estimating the greenhouse gas emissions for industry. So the emission factors remain the same. We would also discuss something about CO2 equivalent and the related concepts for estimating the greenhouse gas emissions for industry. So the objectives are to estimate the carbon footprint for industry, including the detailed calculations and methods of determination of greenhouse gas emission factors. So what contributes to the carbon footprint for an industry? We need to again look at the energy consumption of an industry, just as we had looked into the energy consumption of a family or a household. Similarly, we know that any industry would consume electricity. Electricity would be consumed in a big way. The difference between an household setup and an industrial setup is that the industry would be consuming electricity in a big way for running its machines and for air conditioning. Other things like, say, electricity for lighting, refrigeration, for lifts, they also would consume certain portion of electricity. Electricity would come from the grid. Knowing the emission factor from the grid electricity, one can compute the carbon footprint for this sector. Just as electricity is an important factor, similarly, travel by company vehicles should be considered in calculation of carbon footprint of an industry. So a company vehicle would consume diesel, petrol, or even electric cars, and that should be considered while calculating the carbon footprint. As mentioned earlier, we need to know the emission factor for diesel or emission factor for petrol. We must be sure about the mileage of the vehicle for estimating the carbon footprint. Differently from the family consumption basket is the raw materials. So raw materials in and out of the industry would be considered in the carbon footprint calculations. Factory management taking to air travel for working might form a major carbon footprint contributor, and the consumer goods which are rolled out from the factory gates, the carbon footprint of that would also matter. So for the raw materials and consumer goods, something called as product emission factors need to be considered. We need to be clear about the terminology which industry uses when calculation of carbon footprint. So an industry carbon footprint calculations generally are categorized as scope 1 carbon footprint calculations, scope 2 and scope 3. As is visible from this chart, scope 1 calculations are the direct emitters or direct contributors to the carbon footprint, and they would include the contributions because of the travel from the company owned vehicles, the gases, for instance, used for manufacturing. The gases might be CO2, SF6, methane, CH4, nitrous oxide, NO2, the fluorocarbons and parafluorocarbons. So all these gases might contribute to the carbon footprint, they would come under the scope 1. Scope 2 is the contribution from the grid electricity, not the captive electricity, the grid electricity, which is purchased by that industry to run its machines and other setups. So whatever calculations we have learned about grid electricity would come into the scope 2. Scope 3 would include the raw materials and the product emission factors, the travel by the contractor owned vehicles, the carbon footprint generated from waste management, and the traveling by the employees, especially the air travel. So these are the three categories which we should be familiar with. Why a particular thing is into scope 2, why is it not in the scope 1? That is beyond the scope of the discussion. Okay, this is agreed upon. That is what we can say, right? The basic principles of calculations remain the same. So the emission factors which were discussed earlier, they remain the same when we calculate the carbon footprint from purchased electricity. We calculate the emissions from the diesel owned vehicles, diesel operated vehicles, both the company owned vehicles as well as contractor owned vehicles, or even the oil fired aeroplanes. They would also contribute to the emissions and the product emission factors. So the basic calculations remain the same. The difference when you are talking about industry, carbon footprint of industry, we need to be clear about some specific some specific terms which the industry are required to follow in calculation of carbon footprint. So as we said, the scope 1, which are the direct emissions, they would include generation of electricity, generation of heat, generation of steam from the combustion of fuels, be it in boilers, be it in furnaces, or the utilization of steam in steam turbines within the premises of the company. So that would come under the scope 1, within the premises of the company. Similarly, the transport emissions, the transport carbon footprint of main and material, both including the material also, via the buses, via the cars, via the trucks, all owned by the company, not by the contractors, owned by the company, they would come under direct emissions scope 1. Emissions resulting from the physical processes, from the chemical processes for manufacturing the products like say cement, aluminum, some chemicals, all these emissions from this physical and chemical processes, they would have to be accounted for in the scope 1 calculations. The leaks with the gases, whether it is intentional or whether it is unintentional, that would also go into the scope 1 calculations. Carbon footprint of an industry takes into consideration all the greenhouse gases, not simply the carbon dioxide, because you know that carbon dioxide is an important gas, important greenhouse gas, and that is why we focused on that when you calculated the carbon footprint of family. But in the industry, we not simply focus on the carbon dioxide emissions, we would have to focus on all other emissions, and those emissions are expressed in terms of carbon dioxide equivalent. Now, what is this carbon dioxide equivalent? That we'll see later. Greenhouse gas emissions emitted indirectly and which fall into the scope 2 would include the emissions from the grid electricity and emissions from the thermal energy supplied by the companies. So when we calculate the carbon footprint from an industry for the scope 2, again, we need to remember that scope 2 would include the electricity consumed by the grid, supplied from the grid, and the thermal energy supplied from outside by other companies. That is indirect emissions scope 2. In the scope 3, we would be interested in focusing on the transport upstream and downstream of that industry. By upstream, we mean the transport of the raw materials via the trucks, trains, etc., flowing into the company. And by downstream, we mean the transport of the manufactured products again via trucks, trains, etc., out of the company gates. We would also focus on the business travel, be it by trains, be it by aeroplanes, as well as the employees commuting via buses, cars, etc. So all these four things, that is the upstream transport of raw materials, downstream transport of products, business travel, and the travel of the employees would be covered in scope 3. Mind well that the basic principle remains the same. If it is a truck fired by diesel, the emission factor of diesel has to be considered. If it is a bike powered by petrol, the emission factor of petrol has to be considered. So the basic principle remains the same. And as we said, we need to express all these emissions, scope 1, scope 2, and scope 3 in terms of carbon dioxide equivalent. Now, why the carbon footprint is expressed in CO2 equivalent? Because other gases also contribute to global warming. Okay. And hence, it is a better idea to express the green global warming potential of all the gases in terms of carbon dioxide emitted. Okay. For example, the global warming potential of methane is 28. Now, what is the meaning of that? The meaning is 1 kg of methane emissions is equivalent to the warming potential of 28 such kgs of carbon dioxide, right? So methane is 28 times more potent, more dangerous to global warming than the same quantity of carbon dioxide. Okay, but why then we express it in terms of CO2 equivalent and not in terms of methane equivalent? That is because carbon dioxide in absolute terms contributes more to the global warming. So that is the reason why the carbon footprints are expressed in CO2 equivalent. So the calculations remain the same. How do you calculate the carbon footprint of industry? Carbon footprints for electricity, we need to take the emission factor for electricity per unit. We need to get the electricity bill, calculate it monthly, how much is the electricity consumed annually, and divide it by 1,000. Same thing about road transport. We need to talk about the mileage of the car or mileage of the truck, and we must know the emission factor from the diesel. Okay. So this calculations had already been explained, so I will not go into the detail again. Just have a look at this other gases, other greenhouse gases and their global warming potential. These are the 6 Kyoto greenhouse gases, and these are the sources and these sources are important in industry because industries are the places where you would find these gases being emitted. For example, methane would be emitted from the places where the coal is being mined, from landfills, or where natural gas is being produced. Or nitrous oxide is being emitted from the industries manufacturing, for example, fertilizers or nylon, right? If it is a refrigerant industry, we need to be sure that there would be hydrofluorocarbon emitted, okay, leaked, gas leaked, okay, and that is to be understood. Same thing about aluminum, perfluorocarbons would come from that. In the switchgear industry, there would be sulfur hexafluoride. So these sources we need to understand, and that global warming potential needs to be considered while converting that into the equivalent CO2 emitted. Okay, so the carbon footprint for an industry is expressed not simply as the CO2 emitted, it is expressed as CO2 equivalent, and it is expressed in tons of CO2 equivalent. Okay. For example, this case study, which is in front of you, would help us clarify the concepts, how to estimate the total greenhouse gas emissions. Okay. This industry, for example, emits 10 tons of CO2, 100 kgs of methane, and it consumes as the raw material 0.2 kgs of hydrofluorocarbons. So how much is the carbon footprint of this industry, right? So how do we calculate that? So we need to calculate the CO2 equivalent from methane, right? So it is 100 kgs means 0.1 tons, 0.1 tons into 28, because that is how is the multiplier for methane. So 0.1 into 28 is 2.8 tons of CO2 equivalent. Similarly, for HFCs, whose quantity is very small, you see, it is 0.2 kgs, but because its multiplier is 12,400, it does contribute significantly to the carbon footprint. So look at this number, 0.0002 tons of hydrofluorocarbons multiplied by 12,400 gives you 2.48 tons, right? And this way, if you add this 2.8 plus 2.48 plus 10, that comes to be the total greenhouse gases, the total carbon footprint of an industry which is consuming hydrofluorocarbons and methane along with emissions of CO2. So in this case, for example, the carbon footprint works out to be 15.28 tons of CO2 equivalent. Similarly, as was explained earlier, the emission factors for electricity coming from coal-fired plant is 1.04. For diesel-fired captive power plant, it comes to 0.59. For a gas-fired power plant, it comes to 0.43. And if there is a grid electricity with 80% coming from coal and 20% coming from clean sources, that emission factor comes to 0.82. This was already explained to you. And for per liter, because in industry, you know that petrol would be consumed, diesel would be consumed, could be that there is CNG and LPG consumption. For that, the emission factors are given as petrol, for example, is 2.22 kgs is the emission factor. For LPG, it is 2.95. For CNG, it is 2.93. For diesel, it works out to around 2.6 kgs. Okay. So these numbers we can always calculate, but it's a good idea to remember also. This is the method for calculating the CO2 emissions for electricity. And this was already explained to you that this calculations would require the data of the fuel consumption. You need to know the ultimate analysis of the fuel and the emission factor for that. You also need to know the electricity consumption and the emission factor for electricity, and you must know the source of electricity for calculating the emissions. Same goes with the other products. Now, this important term you need to understand that if you are talking about products like cement, like aluminum, okay, like paper, which are more energy intensive products, then generally you would have something called as product emission factors. Okay, these product emissions factors are arrived at by doing a very detailed energy audit, okay, by professional agencies. For example, one such value is listed over here, and that value is the CO2 equivalent for thermal energy from a cement unit is 0.23 tons per ton of cement, and the same cement industry would require electrical energy for which the CO2 equivalent comes out to 0.06. Okay, all in all, the total, that is 0.23 plus 0.0604, that total would be the total product emission factor when one talks of a cement production facility, right? So this way you would have some data on product emission factors, and that can be easily used for calculating the emission factors of the products like cement and aluminum. Okay, I hope this clarifies the concepts of calculating the greenhouse gas emissions, the carbon footprint of industries. See you. Bye.